everyone is doing well. I'm William Swan, and I had the pleasure of working in the mechanical workshop with Marcus Clement and Ben Scholl under their supervision. My project for the Fitzpatrick Lab is the MMSM, or Modular Mounting System for Microscopy. Currently, laser scanning microscopes are often made for specific purposes, particularly those designed for in vivo imaging of intact brain circuits. Because these microscopes are optimized for living specimens, they are difficult to use in other capacities, such as in vitro or imaging in dish. The current setups have an extreme lack of modularity, making it time-consuming to change out 3D micromanipulators and move positions for the specimen. The modern in vivo scope in the top right is the one my mentor currently uses. While it has flexibility in 5 axes, there's plenty of empty space, making it difficult to set up for different configurations. In the bottom right, this multi-photon scope can do in vitro imaging very well, but has very limited z-axis movement, making it difficult to use in other capacities. It is built as one piece, so it is inflexible and very limited to what setups it can use. We wanted to design an assembly that can easily change between in vivo and in vitro preparations. In vivo imaging allows one to study intact circuits and their activity in response to sensory inputs. For example, one could examine the activity of visual cortical neurons while stimulating the eyes with different kinds of light shown in the figure on the left. In contrast, in vitro, or slice physiology, allows you to measure more detailed physiological properties of these neurons and do far more intricate experiments. For example, one could even go back and find the same cells imaged in vivo to make correlative measurements. The problem, as I mentioned earlier, is that laser scanning microscopes are often made for specific purposes. This project creates a modular mounting system to expedite the process of mounting while simultaneously allowing for both types of imaging with the same optical configurations. For in vivo imaging, the microscope needs to be further away because an intact living specimen is being examined. Additionally, the scope needs to move easier and longer distances. For in vitro imaging and dish work, the entire apparatus needs to be raised so the slice or dish is at the same imaging plane, as well with a rigid microscope that can do very precise movements. The MMSM expedites the process of mounting with its unique snap-on, snap-off design, while simultaneously allowing for both in vivo and in vitro imaging with the same optical configurations. The 5 different height options, combined with vertical z-axis movement on the microscope itself, allows for any height necessary. I designed this mounting system to be optimized for the ability to hold large plates, since a sizable surface is critical for precise examination. I designed custom mounts for the 3D micromanipulators from Sutter Instruments. These mounts allow for flexibility in placement without removal. The MMSM provides this flexibility while allowing for easy removal and changing of components into imaging trays. The 5 different height levels will be accessible by moving it to different height layers and inserting 8mm dowel pins to hold the table at those positions. This animation gives a visual to what the complete setup would look like before we look at each of the individual components. The entire assembly will contain 31 pieces, where 26 will be machined. It will be made out of aluminum and finished with black anodization, except the rods, which will be cut from 303 stainless steel. The majority will be finished with black anodization, not only to look nice, but to prevent accidents. For example, if a laser gets misaligned and hits the mill-finished aluminum, it could bounce into your eyes and cause damage. The black anodization prevents this reflection due to its finish. The mounts will swivel and will be tightened with socket head screws to allow for rotational flexibility. Additionally, these mounts are detached and attached with magnets. The snap-on, snap-off system, those are the magnets, is what allows for the quick changement of the 3D micro manipulators to change between these setups. Each custom mount for the Sutter Instrument micromanipulators will allow for C-axis movement with the rails allowing for X or Y movement. 2, flexibility in placement is important so you can get precise readings. This is what the complete assembly along with a Thorlabs microscope and LED lamp will look like in a realistic view. Consider moving one of the micro manipulators. You can see the 4 axes of freedom that they have. This project is designed in SOLIDWORKS and programmed to the milling machines using SolidCAM. All of the 3D parts that were designed were made into 2D to be on paper for universal machining instructions. Here are 2 of the prints that I made for the parts that will be machined out. Each part has very minute details such as air holes at the bottom of the pipes to eliminate excess compression, dowel pins to allow for easy detachment, and many individual parts to allow for easy machining. I would like to thank Marcus Clement, Nicole Holstrom, and Abraham Rivera for teaching me everything I know about machining and helping me with the design and prints the entire 6 weeks. I would also like to thank Ben Scholl from the Fitzpatrick Lab for assigning me a challenging project along with giving me guidance the whole internship. Finally, I'd like to thank Ilaria, my fellow interns, and the rest of the MPFI community for making these 6 weeks just amazing. Special thanks to all the donors who made this internship a wonderful experience. Thank you for your time, and do you have any questions?
Do we have questions?
The hydraulic system be more accurate and be more...
A hydraulic system will make it easier to move, but it would also raise the cost, and that's one of the issues I was trying to solve with this project, make a less expensive microscopy setup. So it has 5 pre-designed height layers, but the Z-axis movement on the microscope, along with the 5 different height layers, will get you any height necessary for examining the specimen.
Not a question, but I just want to thank you for bringing the real thing, get some sense of scale. Thank you.
Thank you so much.
Oh, thank you.